One more thing about chapter 4, and that is we learned about the principal branch. So make yourself 6 of these, and basically the principal branch is saying get the 2 quadrants you need and not the other 2 that are duplicates. Long story short, it means since the unit circle goes around and around and around, which is where the arc part of the formula comes from, that's when you add the 2 pi n, you add the 360 n. The principal branch says, I want to know just the 2 quadrants that keeps this a function. Which means you need 1 quadrant where everybody is positive, and you need 1 quadrant where everybody is negative. The principal branch is the opposite idea of coterminal and arc sign, which says keep going around and around and around until you find all your answers. Okay? So, one thing about the principal branch, it always includes quadrant 1. Then it will include 1 other quadrant. And it'll include a quadrant that is adjacent to quadrant 1. So it will include either quadrant 2 or 4. Okay? And all you have to do, I should have just put pluses here. All you have to do is figure out where the minus is. So for sine, do you go to quadrant 2 or 4 to get negative values? 4. Okay. Shh. That's why these are the 2 quadrants for the principal branch. That's why. And we call it negative pi over 2 to positive pi over 2. Because we're thinking in radians. For cosine, do you go to quadrant 2 or 4 to pick up negatives? 2. That's why those are the 2 quadrants for the principal branch. And they write it like this, 0 to pi. When we get to the other 4, it gets slightly more tricky. Because both of these quadrants have negatives. Well, okay, so let's do the other 2 that are easier. So where do you go to get negative values of cosecant? Quadrant 4. Where do you get negative values of secant? 2. So this is the principal branch for sine and cosecant, isn't it? And this is the principal branch for cosine and secant, isn't it? Now, when it gets to tangent and cotangent, you've got some options. And so the idea is try not to cross an asymptote. So if you have a choice between 2 or 4 for these 2, try not to cross an asymptote. So since tangent is sine over cosine, where's its asymptote? At 90, right? Everybody agree? That tangent has an asymptote at 90 because cosine of 90 is 0, right? So therefore, which is the better quadrant to use? 4. On the other hand, cotangent's cosine over sine. Where's the asymptote? At 0. So which quadrant's the better quadrant? 2. Okay? So the principal branch for tangent is also negative pi over 2 to pi over 2. And for cotangent is 0 to pi. And that's really all that principal branch was about. It was about how do you limit arc sine and arc cosine that keeps wrapping around the circle over and over. How do you limit it so that its inverse will be a function? That's basically what it is. If we asked you to find the domain and range of y equals arc anything, arc sine, arc cosine, arc tangent, we're talking about a relation. Then the domain and the range are just going to be the inverse of the domain and the range of the regular problem. But if we ask you to find the domain and the range of inverse sine, or inverse cosine, or inverse tangent, now this is function notation. The implication is that it is a function. Therefore, when you give the domain and range, you would never say all real numbers. So, what is the domain of y equals cosine theta or y equals sine theta? What did we say the domain was? All real numbers. What did we say the range was? Y is an element from -1 to 1. Last year in Algebra 2, you learned that when you found an inverse, the domain became the range and the range became the domain. So if you were finding the domain and the range of arc sine or arc cosine, the relation, since the domain of the regular function is all real numbers, the range of the relation will be all real numbers. Since the range of the function is y is an element from -1 to 1, the domain of arc sine or cosine will be x as an element from -1 to 1. However, when we use this notation, since the domain is all real numbers, the range cannot be all real numbers. When you have this as a function, so I think I just confused myself slightly, so I want to repeat this again. Okay. Here's your parent function, y equals cosine x, y equals sine x. Its domain is all real numbers. Arc sine and arc cosine will then have a range that is all real numbers because it's the inverse of the function. Okay? So this one had a domain of all real numbers. This one has a range of all real numbers. Why? X and y switched places. Since this one had a range that y is an element from -1 to 1, this will have the domain is x as an element from -1 to 1. Okay? Parent function, arc sine cosine the relation, inverse cosine or sine the function. The domain will still be x as an element from -1 to 1, but the range will not be all real numbers. It will be the principal branch. Because this is a relation, it doesn't pass the vertical line test. This is a function, it does. Okay? So for this, the range would now need to be whatever the principal branch was. So if it's sine, it's -pi/2 to pi/2 for the range. If it's cosine, it's 0 to pi as the range. Okay? Does that make sense? Yes?